This is the first lecture on basic loads on aircraft. It is also my first appearance in this lecture series, so I will briefly introduce myself. My name is Jos Sinke and I'm assistant professor at the Faculty of Aerospace Engineering of the TU Delft. My specialty is materials and manufacturing. To start this lecture, I would like to ask you to look at the following pictures. These persons are pioneers of flight. They have been working on and contributing to the first flights and the development of aviation. Take a brief break to guess who those persons are. Or in other words, do you know who is who? These are the names of the 6 gentlemen. First, George Cayley. He was a 19th century English pioneer who indicated that the different functions of an aircraft, like lift and propulsion, should be separated. At that moment, most pioneers thought of flapping wing vehicles. Next to him are the Wright brothers. These men are famous for the first flight of a controllable, engine-powered aircraft. I will tell more about them later in this lecture. Mr. Langley was a competitor of the Wright brothers. He tried his aircraft a few weeks before the first successful flight of the Wright brothers, but he failed. The last two, Anthony Fokker and Albert Plesman, are famous Dutch aviation pioneers. Fokker has built many aircraft, and even today there is still a company bearing his name. Mr. Plesman was the first administrator of the KLM, one of the oldest airlines in the world. In addition to these pioneers, I will mention one more. Otto Lilienthal was a German pioneer who performed all his flights in the 19th century, just before the first powered flight took place. He was an engineer who built many non-powered gliders, which he tested from a hill in Berlin. He made more than 2,000 flights with these gliders. Unfortunately, he died after a crash in 1896. In the picture on the left-hand side, you see one of his designs. On the right-hand side, you see a bat, and you can clearly see the resemblance of Lilienthal's design with the wing of the bat. Far descendants of Otto Lilienthal's gliders are today's hang gliders. These hang gliders fly from high ground and try to pick up some thermic to stay in the air as long as possible. What is a common glide ratio for a hang glider? Note that the glide ratio is the ratio of the horizontal distance for the descent of 1 meter. For common hang gliders, this might be 17:1, whereas for gliders with fixed wing, this might be 20:1. Another question is, gliders often run down a hill to generate speed. Do you think that the wind direction is of any influence? The answer is yes. What really matters is airspeed. So if we run downhill with a headwind, your airspeed is higher and you can generate more lift. That's also the reason why aircraft preferably take off or land with a headwind. In both cases, the required length of the airstrip is minimal. Let's return to the pioneers of flight. The Wright brothers were the first people who flew their aircraft named the Flyer, a powered and controllable heavier-than-air vehicle. Although the flight was very short, the principle of flight was proven. In this short video, taken a few years later, an improved Wright Flyer is shown, which flew almost 1 hour with 2 persons on board. The question may arise, why were the Wright brothers first? Well, they had a number of advantages over other pioneers. They had manufacturing capabilities in their printing firm and bicycle shop they owned. They also were very interested in flying, and they followed other pioneers in their attempts, like Otto Lilienthal. They also performed quite a lot of tests themselves on their engine, wing profiles and propeller. Next to that, there was pressure to speed up the process, and the time for flying has come. If the Wright brothers would have failed, probably another pioneer would have had the honor of a first flight shortly afterwards. The Wright Flyer was a very successful aircraft in those days. Several upgrades of the Flyer were made, and on their European tour in 1908, they used the demonstrator aircraft we saw in the video, which was a derivative of their first Flyer. The Wright Flyer was the first heavier-than-air aircraft. It used wing warping and horizontal stabilizers in front of the aircraft to control the machine. Later, the warping, which is a local deformation of the wing, was replaced by moving wing parts like ailerons. Also, the wing and the engine of the Flyer were very efficient when compared to competitors. The aircraft history, though still very short, has a lot accomplished since then. Look, for instance, at the differences between the Wright Flyer and a modern jet, in this case an Airbus A320. Before ending this first lecture, I would like to introduce the main forces acting on an aircraft. If we assume a steady horizontal flight, we may distinguish four forces. First, the weight, the downward force representing the weight of the aircraft. Then the lift, which is generated to counteract the weight. Third, the drag, the resistant force that is experienced when moving through air. And finally, the thrust, needed to overcome the drag. When flying at constant speed and altitudes, the equilibrium equations are simple. Lift equals weight, and thrust equals drag. When we look briefly at these forces, we can tell the weight of the aircraft includes the aircraft empty weight, the payload like passengers or cargo, and the weight of the fuel. The lift is generated by the wing, with a small contribution of the horizontal tailplane. The drag is caused by friction between the aircraft surfaces and the air, and by pressure differences around the aircraft. All aircraft parts contribute in this drag, the fuselage, the tail, etc. And finally, the thrust is provided by the engines. In the next 3 lectures, we will discuss all these forces in more detail.